Question 8b. Find the probability of getting a sum of 7 if a die is rolled 2 times. The sum of 7, like 1 add 6 is 7. 2 add 5 is 7. 3 add 4. 4 add 3. 5 add 2. 6 add 1. So those has 1, 2, 3, 4, 5, 6. Total have 6 out of come. Out of total 36. 6 times 6, 36. Cancel 6. So the sum of 7 is 1, 6. Then C. Find the probability of getting 2 different number. 2 different number. That is the same as 1 minus probability the 2 same number. Total is 1. And take off 2 same number. 2 are same number. That's 2 different number. So how many 2 outcomes are 2 same number? So you look at this total 6 by 6, total 36 outcomes. The 2 number are same number are in this diagonal. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. 1, 2, 3, 4, 5, 6. And the others are 2 different number. So have a 6 are same number. So the probability to get 2 same number is 6 out of 36. And cancel common factor 6. Get 1, 6. 1 minus 1, 6. 1 is a 6 out of 6. Minus 1, 6 is a 5, 6. Let's get 2 different number because there are 30 outcomes. 30 out of 36 reduce is a 5, 6. Then next question, question 8. In a class, there are 17 junior. So given. So we for this table, junior, senior. There's on junior has 17 junior. So under the junior, you put 17. And there are 12 senior. So under senior, you put 12. I have a senior is 12. 7 of the senior are female. Senior female is 7. And the 9 of the junior are male. Junior male is 9. If a student is selected at random, find the probability of selecting the following. So we need to complete this table. So here, 12 minus 7, you got this 5. Senior is total is 12. Have 7 is a female, so have 5 male. And 17 minus 9 got 8. So for junior, total is 17. Male, it's 9. So female, it's 8. So then how many male? 9 add 5. 14 male. How many female? 8 plus 7. 15 female. So this male 14, female 15, add together, total 29. Junior and the senior. Junior 17, senior is 12. Add together, total also 29. So total is 29. So question asks you, find the probability of a senior or a female. So looking for probability of senior or female and use addition property, addition rule. And probability of A or B equal probability of A plus probability of B event minus probability of A and the B event. So then this probability of senior or female is equal probability of senior plus probability of female minus probability of senior and the female. So probability to get senior, because senior is 12 out of total 29. Female has 15. So probability to get female is 15 out of 29. Probability to get senior and the female is 7. So probability is 7 out of 29. They have same denominator 29. So it's 12 add 15 minus 7. So it's 12 is 5 plus 7. 15 is 8 plus 7. This is double counting because 8 add 7, already including this 7. 5 and 7 add together is 12. So 12 add 15. This 7 counted twice. So you have to take off 7. You can count 5 add 7 add 8. That is 20. So that is double counting. We have to take off. And the next one, it's question B. B is a senior or junior. Probability of senior or junior is equal probability of senior plus probability of junior and minus probability of senior and the junior. So what is the probability of senior? Total is 29. How many senior? Senior has 17. 12 out of 29. And plus probability of junior. Junior is 17. So it's 17 out of 29 minus probability of senior and the junior. And there is impossible for one student. The status is junior, also senior. So there's no students, senior and junior. They are mutually exclusive. There is no one students. The status is junior and also senior. Students can be only junior or can be only senior. So it's 0 students. So probability to get junior and the senior is 0 out of 29. So 12 add 17 is 29 out of 29. Divided is 1. 100% you can get a students either junior or senior. And C is a probability of junior who is female. So you want to get probability of junior and the female. So total 29. How many students is junior and the female? 8 students. 8. Junior and the female, 8. So probability is 8 out of 29. And D, a junior or a male. So we want probability of junior or male. So equal probability of junior plus probability of male minus probability of junior and the male. And the probability of junior, because junior has 17 and male has 14. Male has 14. Junior has 17. So probability to get junior is 17 out of 29. Probability to get male is 14 out of 29. Minus probability of junior and the male. Junior and the male, it's 9. Junior and male, it's 9. So it's 9 out of 29. Subtract and figure out the 22 over 29. Next question, question 10 is an apartment question. There is an apartment building has the following distribution of apartments. 1 bedroom, first floor, 2 bedrooms, 3 bedroom, and the first floor, second floor, third floor. So then we need to figure out. First of all, 1 bedroom. How many 1 bedroom you add together? 5 add 2 add 3. Total is 10. 1 bedroom. How many 2 bedroom? 3 add 5 add 3, total 11. 2 bedroom. How many 3 bedroom? 0 add 4 it's 8. So how many on the first floor? How many room on the first floor? 5. How many apartment? 5 add 3 add 0, it's 8. How many apartment on the second floor? 2 add 5 add 4, 11. How many on the third floor? 3 add 3 add 4, 10 apartments on the third floor. So you add together first floor, add second floor, add third floor apartments. Total is 29 apartments in this building. And this side, 1 bedroom 10, 2 bedroom 11, 3 bedroom 8, 10 at 11 at 8, also 29 total. Total 29 apartments. Now question asks you, if an apartment is selected at random, find the following probabilities. A, it is not a 3-bedroom apartment on the second floor. So you want probability of not 3-bedroom on second floor. So equal to 1 minus probability of 3-bedroom here. Second floor is here. 3-bedroom second floor is this one. You don't want this. You can be the others. So it's 1 minus probability of 3-bedroom second floor. And can be the others, just not this one. So it's 1 minus probability of 3-bedroom on second floor. So it's equal minus probability 3-bedroom second floor is 4 out of 29. And remaining has 25. 29 minus 4 is 25 apartments. It's not 3-bedroom 2 on the second floor. On 3 bedroom on second floor, 3-bedroom have 4 apartments. 29 minus 4 has 25 apartments. It's not 3-bedroom apartment on the second floor. And question B, it is either on the third floor or a 2-bedroom apartment. So we want to figure out probability of third floor or 2-bedroom apartment. Third floor 2-bedroom apartment. So that's equal to probability third floor plus probability 2-bedroom minus probability third floor and 2-bedroom. So third floor has a total is 10 apartments. Probability is 10 out of 29 plus probability 2-bedroom total 11 out of 29 minus third floor and 2-bedroom. Third floor and 2-bedroom is 3 apartment, 3 out of 29. And figure out 10 at 11 minus 3, it's 11. 11 out of 29. Then question 18 out of 29, I'm sorry, 18 out of 29. Question 11. It is reported that 75% of working women, so given P equals 0.75, are working women, use computers at work. Choose 3 working women, so N equals 3. Choose 3 working women at random. Find the probability that none of the 3 women use computers at work. So they don't use computer. So probability use computer is 0.75. And do not use computer is Q. Q equal 1 minus P. And 1 minus 0.75, get 0.25. So probability for a woman, do not use computer is 0.25. And here want to be 3. So probability of none of the 3 use computer. So it's equal probability first woman not use computer times probability of second woman not use computer times probability of third woman not use computer. So first woman do not use computer is 0.25. Second woman do not use computer also 0.25 times the third woman not using computer is also 0.25. So the 3 times together become 0.25 to the power 3. You can use calculator, you will get is 0.015625. Or because 0.25 is 1/4, 1/4 to the power 3. 1 to the power 3 is 1. 4 to the power 3 is 64. And you can answer in fraction or in decimal. In fraction is 1/64. Then at least one of the 3 women use computer. So as you looking for probability of x greater than or equal 1. So that means one, you need to figure out probability of 1 woman use computer, add probability of 2 women use computer, add probability of 3 women use computer. So if you want to figure out the 3 probability is take a long time. So there is a quick way to do it. It's the same as the whole probability is 1 minus probability of x equals 0, which is none of them, which is this one. Probability of x equals 0. None of the 3 using computer. So it's equal 1 minus none of the 3 using computer. Probability is this. 1/4 to the power 3 is this one. 0.25 to the power 3. 0.25 is 1/4 to the power 3. So it's equal 1 minus 1/64. Previous one here. And the 1 is 64/64. Minus 1 is 63/64. You can answer with fraction or you can go decimal number. And they are equal. Then next question, how many possible ways are there to hang 7 picture on a wall? So you have the first position, you can have 7 choice. 7 picture, you can choose one of it from those 7 pictures. So have 7 choice. So so the first one is 7. Second one, the first one you choose 1 picture, remaining 6 picture. So have a 6 choice for the second position. Then next, once you chosen 2 pictures for first and the second, remain 5 picture for the third position. Then once you choose next is a 4 choice, then next 3 choice, then next 2 choice, until only remain 1 picture. So it's only 1 choice and time together. This we call 7 factorial. This we call 7 factorial. 7 factorial, you time together 5,040 ways, possible of ways. What's that means? If you only have 2 picture, like 2 pictures, like A and B, you can put A and B, or you can put B and A. So 2 choice, 2 factorial, 2 factorial, 2 times 1 equal 2. If you have 2 picture, so hang on the wall, have 2 of it, 2 outcomes. If you have 3 picture, like ABC, you can put ABC, or you can put ACB, or you can put BAC, or BCA, or CAB, or CBA. So you have 6 outcomes, which is 3 factorial. 3 is 3 times 2 times 1. Then you have 6 factorial. Then if you have 4 pictures, you are going to hang on the wall. Then you have 4 factorial. 5 pictures, 5 factorial. Now here is 7 pictures, 7 factorial. Like this one. For first position, you have 3 pictures. You can have 3 choice. Once you choose one, remain 2 choice for the second position. Once the 2 chosen, the last position only remain 1 choice. So 3 times 2 times 1 equals 6. And question 13. Find the mean, variance, and the standard deviation of the distribution shown below. So mean is this is we call distribution, discrete distribution, probability distribution, discrete probability distribution. The mean is a summation of x times p of x. X is 1 and probability is 0.27. If x equals 3, probability is 0.39. So you time together 3 times 0.39 plus x is 5 times probability is 0.34. Then add together, mean is 3.14. And the variance formula is this. Sigma squared is equal summation of x squared times probability of each one. Add together minus mean square. So it's x squared. X is 1. 1 squared. Probability is 0.27 plus 3. X is 3. 3 squared times probability is 0.39 plus 5 squared times probability is 0.34. Those add together minus mean square. Mean is 3.14 square. And use calculator, figure out this, 2.4204. Then standard deviation is always the variance take square root. So it's 2.4204 take square root. And you use calculator, you can get 1.4408. So use the formula for the discrete probability distribution for the mean formula, variance formula. And question 14. If 3%, so given p equals 0.03, 3%, move decimal point to the left 2 positions, 0.03, of calculator are defective. So probability of defective of one calculator is 0.03. Find the mean, variance, and the standard deviation of a lot of 200 calculator, n equal 200. So this is a binomial distribution because either defective or non-defective, only two outcomes. Probability defective is 0.03. Probability not defective is Q. Q is equal 1 minus P. 1 minus 0.03 is 0.97. Now then for those binomial distribution, the mean formula is mean equal n times p. N is the total is 200 times p. P is 0.03. Time to get is 6 calculator is the average. Have in 200 in 100 calculator have 3 calculator is a defective. 3% means each 100 calculator have 3 calculator are defective. Now if you have 200, so doubled, you will have 6 calculator are defective. This is the mean. And the variance formula is for the binomial distribution is NPQ. N is 200, P is 0.03, Q is 0.97. Time together is 5.82. Take square root. 5.82. Variance take square root is standard deviation. 2.44125 calculator. Question 15. It's if a person roll doubles when she tosses 2 dice. So here has 2 dice, dice 1 and dice 2. And dice 1 have 6 number, dice 2 have also 6 number. You can list out those total 36 outcomes. And the doubles is in this diagonal. Double is show 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So if roll doubles, she of 2 dice, she win $18. For the game to be fair, how much should she pay to play the game? So first of all, if a probability of double is those 6 are doubles out of 36. So probability to P for win the game is 1/6. Q is 1 minus P, lose the game. It's 1 minus 1/6 is 5/6. So P equal 1/6 is a roll double probability. Q is not double, is 5/6. So if a roll double, win the game. If not double, lose the game. So let question ask you how much to pay in order to make the game fair. So you assume it's Y dollars. Y is the dollars she pays to play the game. So Y dollars. So first of all, probability of X. If probability is 1/6, that means is roll doubles. It's 1/6 that win the game. If win the game, she wins $18. $18, and you have to take out. She pay Y dollar to play the game. So actually, gain is 18 minus the earning is 18 minus take out cost Y dollars. 18 minus Y. That's actually gain. 18 minus Y dollars. Probability if a 5/6 is lost the money. Lost how many dollars? Y dollar, because pay Y dollars to play the game, and then you don't run double, you lost the game. Probability is 5/6. So then what's actually gain is negative Y dollars. Y dollars is what she paid to play the game, so it's negative Y dollars. Gain is negative Y dollars. So expect value is a summation of X times P of X. It's the same as the mean of discrete probability distribution, same formula. Expect value is just the mean. So it's X times probability. So X is 18 minus Y times 1/6 plus negative Y times 5/6. So then 18 minus Y over 6 plus negative 5Y over 6. Same denominator is 6. Numerator 18 minus Y add negative 5Y. So same denominator is 6. 18 negative Y add negative 5Y is negative 6Y. So we got this. And to be fair, how much should she pay to play the game for the game to be fair? To be fair means expect value is 0. Expect value is simplified is this one. That means 18 minus 6Y over 6 need to be 0. Expect value is 0. So let this equal 0. Solve for Y. Since this is 0, that means 0 times 6 equal 18 minus 6Y, or times 6 both sides. 6 cancel, get 18 minus 6Y equal 0 times 6 is 0, which is numerator need to be 0. 0 divided by 6 will be 0. So 18 minus 6Y should be 0. Then you got add the 6Y both sides. You got 18 equals 6Y. Then you divide it by 6 both sides. 6 cancel. So Y equal 18 over 6 is $3. She should pay $3 to play the game. Then question 15 and the question 16. A lottery offers 1,000 prize, 4 500 prizes, and 8 100 prizes. 1,000 tickets are sold at $5 each. Find the expectation, which is expect value, if a person buys 1 ticket. So first of all, we created this table. First of all, probability of $100 price, pay $5. So actually, if play the lottery, if get is 1,000 price, probability, because only 1 out of 1,000, so probability 1 out of 1,000 to can get 1,000 price. So actually gain is 1,000 minus cost $5 to play the game. So it's a 995. Then there are 4 tickets. Price is $500. 4 tickets out of 1,000. Total 1,000 tickets. Have 4 tickets. Price is $500. So if get 1 ticket is 500 price, probability is 4 out of 1,000. And actually gain is 400 minus $5. That's the pay to play the game. So 500 minus 5 is 495. Then there are 8 tickets. The price is 100. So if you play the game out of 1,000, so you get a ticket by 1 ticket is a 100 price. Probability is 8 out of 1,000 to get 100 price. Probability is 8 out of 1,000. And actually gain is 100 minus 5, which is $95. Then remaining 1,000 total tickets minus 1 add 4 add 8, total 13 tickets, and remain 987 tickets. There's no price. Have a and lose $5. So actually gain is -5 because pay if you can get the tickets without price, the probability is very big, 98.7%. And 98.7% you will get tickets with no price, and you lose $5. So actually gains -$5. So then you find out expect value. Expect value is x times probability. So it's 995 times 1,000, add 495 times 4,000, add 95 times 8,000, add -5 times this 987 over 1,000. And denominator is 1,000. Numerator 995 times 1, 995 plus 495 times 4 plus 95 times 8 plus -5 times 987. Those numerator add together is a -1,200. Divided by 1,000 will be -1.2. And you can put 0 is the same. So the expect value is -$1.20. So if you got expect value is negative, so that's this game is not in favor of player. Your expect value is negative. It's not in favor in the players. Question 17. The probability that federal income tax return will have 0.1, 012 errors. Income tax return will have 0 or 1 or 2 errors. Have 0 errors. Probability called P1 is 0.73. If 1 error, x equal 1, the probability is 0.23. That's we call P2. And for 2 errors. If x equal 2 errors, the probability is 0.04. Then you can add those together. It should be 1 equal 1. 0.73 add 0.23 add 0.04. It should be 1. If not equal 1, then it is not the distribution. It's not probability distribution. Has to be equal 1. The sum of the probability need to be equal 1. Then that is a probability distribution. Then now here say n equal 10. If 10 randomly selected returns are audited, 10 tax return, 10 you selected 10 tax return are audited. What is the probability that 8 will have no error? So x1 equal 8, no error, 0 error. And x2 is 2 will have 1 error, 1 error. x2 is 2, 2 will have 1 error. And 2 error, none, 0. x3 equals 0. There's no errors, is 0. No 2 errors is 0. And this one we call more than 2. It's not binomial, it's a trinomial distribution. We call multinomial distribution. Multinomial distribution probability use this formula. This formula is n factorial over x1 factorial times x2 factorial. Between them is multiplication. Multiply x3 factorial and times p1 to the power x1 times p2 to the power x2 times p3 to the power x3. So plug in. N equal 10, plug in 10 factorial. x1 is 8, so 8 factorial times x2 is 2, 2 factorial times x3. x3 is 0, 0 factorial. x1 add x2, x3. 8 add 2 add 0. Totally is 10. It should be equal n. So probability 1, which is 0 errors. You don't get any errors. Probability is 0.73. So 0.73 to the power 8. Because here say have a 8. Question asks you find out probability. A will have no errors. So to the x1 is 8 to the power 8 times 2 will have errors. 1 error. 1 error probability is 0.23 and have 2, so to the power 2. And 0 has 2 errors. Probability for 2 errors is 0.04 and have 0. So to the power x3 is 0. Put 0 here. Then figure out this. 10 factorial is 10 times 9 times 10 times 9 times 8 factorial. Cancel with denominator 8 factorial. 2 factorial is 2 times 1. 0 factorial always equal 1. So then 10 divided by 2 is 5. So 5 times 9 is 45. Times 0.73 to the power 8 times 0.23 square. And this is 0.04 to the power 0 is 1. So those use calculator figure out 0.1920. This we call multinomial distribution. The next one is question 18. It has been reported that 4%, so P equals 0.04 are given, of all cars on the highway are speeding. 4% are speeding. If the speeds of 5 random automobiles, so n equal 5, are measured while radar and use the Poisson distribution to find the probability that following. So here, P equal 0.04. So Q equal 1 minus P. 1 minus 0.04 get 0.96. So 4% speeding. 96% is not speeding on the highway. So first of all, we check lambda. Lambda equal n times P. If n times P for Poisson distribution mean is n times P, is the same as the binomial distribution, the mu. The mean is n times P. For the Poisson distribution, the mean we use lambda represent. N is 5, P is 0.04, time together is 0.2, is less than 5. And also check n times Q. N is 5, Q is 0.96, time together is 4.8, is also less than 5. Both are less than 5, then we can use Poisson distribution. You need only when both NP and NQ both are less than 5, then we can use Poisson distribution. And here is a Poisson distribution formula. Probability of X lambda. X for 0 cars, so X equals 0. X is how many cars? Lambda is NP is 0.2. Plug into this formula. E to the power negative 0.2 times lambda is 0.2 to the power x. X is 0, no cars. Over x is 0 factorial. 0 factorial is 1. 0.2 to the power 0, also 1. So time together, you got e to the power negative 0.2. Use calculator. We got this. And round it to 81, 87. 81, 87. 87. Rounded. And 1 car are speeding. So x equal 1. Lambda is still 0.2. So use this formula and get e to the power negative lambda. Lambda is 0.2. And lambda is 0.2 to the power x is 1 and 1 factorial. So you will get is 0.2. 1 factorial is 1. And 0.2 times e to the power negative 0.2. And then which is this one? You times by 0.2, you got this. Next one, 2 cards. So x equal 2. Lambda still 0.2. Plug into the formula. X factorial is 2 factorial. E to the power negative lambda. So e to the power negative 0.2. Lambda to the power x. Lambda is 0.2 to the power x is 2. So this one figure out 0.2 to the power 2 is 0.04. 2 factorial is 2 times 1 is 2. And this reduce it is 0.02. Then e to the power, then figure out this one. You got this answer. Use calculator. Then next, 3 or more cars are speeding. So that means find out the probability of x greater than or equals 3. And the lambda is equal 0.2. Use Poisson distribution. So it's the same as 1 minus greater than 3, more than 3. So you take off when x equals 0, when x equals 1, when x equals 2. Those you take off. That's become for x greater than or equals 3. And before 3 is 0, 1, 2. It's not counted. So total is 1 minus the 3. So 1 minus x equals 0 is come from A. Come from A. You guys 81, 87, 0. You got this number A. And add when x equal 1 is this number. And add x equal 2 is this probability. So the 3, A, B, C, the previous 3 questions add together, probability add together, and subtract from 1. 1 minus those three probabilities, then you will get this is the probability for 3 or more than 3 cars are speeding.